today, and the speaker Dr. Manoj is with us. Dr. Manoj sir is in NIT Srinagar, and he will deliver a lecture how to irrigate with atmospheric air. So that is very important lecture related to your training program. So please interact with Dr. Manoj sir.
Okay, fine. Good morning to everyone. My name is Dr. Manoj Kumar from Mechanical Engineering Department, NIT Srinagar. This is the main topic which I want to cover is the water generation from atmospheric air. Although this is for fear nowadays, it is a very common technique which is we are exploring it now. A few years back, it was a bit of challenge that how to tackle the scarcity of the water. Fine. This will be my content of my presentation. So, now the very famous Leonardo da Vinci. We always talk about this. We have a very common name for it. So he's saying that water is the driving force for all the nature, right? And if we keep this in mind that yes, we need to have enough water if we want to survive on this earth. And along with this, we have a aim by the Indian government that is a Sustainable Development Goal 6, which is we have to achieve a universal or equitable access of the safe water to all persons, right? So this is by this typing mistake is by 2000 till 2030 we are going to achieve this aim. That is one. And regarding this, we are going to do many things. I mean, we are going to generate the new technology where we are going to do so many things. Fine. So now at a present scenario, we see so we are mostly dependent upon the fossil fuels that is present around us, and we are going to use that energy for our consumptions. And again, the nuclear fuels which is available over there, we are going to generate the energy. I mean, the fission reaction is going to take place over there, and because of that, the surrounding your fuel is going to be, or the liquid is going to be getting heat up, and we are going to interact that fuel with the water, and we are going to make it in a steam, and we are going to draw it, or we are going to throw it on the turbines so that we could produce electricity. That kind of work is being done, right? So, but when we talk about the sustainable things, then we need to be focused on the something which is can be renewed, right? And for the renewal, we do have a lot of things over there. Solar energy is there, wind energy, geothermal energy is there. We, whenever we the one thing we come in a mind that we want to talk about the solar. Then solar, we always think about that there is a PV panel over there, and we are going to expose that panel to the sun, and we are going to produce electricity. That is the only thing, one thing which comes in your mind, right? But again, you think that there is a question has been asked that how we are going to tackle about that. But we after 25 years, how we are going to tackle that waste, solar waste? That is a separate thing which is going to be a big problem for our country, right? How will you dispose of that? But the one thing is that when we are going to talk about the solar energy, then the kind of electricity going to produce over there, you see morning 11 to 3 hour is the peak time. So intensity is very high at that particular time, right? Morning 11 to 3. So now what is happening over there is that radiation is very high, on almost around 1 or 2 you are going to see a very high radiation over there. But when we need that electricity in the morning hours, when we are going to the office or the schools or our institutes, and in the evening hours when we are coming back to the home. Otherwise, if you see in this room, you are around 20 to 30 people over here, and you are sharing a single AC. But when you are at home, you are 2 persons and sharing a single AC over there. That is the thing over there. Although you will counter this point that okay, there is some kind of heat load is there, so we will accordingly heat load, we are going to go some calculations and we are going to consume that electricity as per that. That is the counterpart for that. But again, we do have, when we go for the heat load calculation, we always have so many factors: how many walls we have, how many sunlight is coming, which part of my room is exposed to the sun, how many walls is under the shadow area. All these factors are always going to be there, and by having and adding all those factors, we are going to calculate the heat load for that. Fine. But the thing is that what is happening over there is, in a peak hours, we are going to share our room with so many people. That is going to happen in an office. Around 100 people are going to share around 5 ton or 10 ton of AC, let us say. If maybe I'm saying it more, but at least 3 to 4 ton of AC is going to shared by the 100 people. But that is not going to happen in the homes, right? So what is happening over there is, your peak, whenever you have a requirement of electricity, you are not going to depend upon the solar energy, because the peak hour is 11 to 3, and at that time you are not going to use that. So initially government has initiated so many programs for that. That we are going to use this PV panel, we are going to use, in Gujarat, there is some river over there, Narmada, I believe, and on that they have floated panel over there. They are going to produce it, right? But they are not going to utilize that, right? So alternately, they are saying now we are going to working on that batteries, right? On a battery we are going to store it. But again, storage is again problem. There is a huge loss. Again, the delta T is going to be very high, and your loss is going to be very high. So your storage, that is not going to give you that much of capacity which you are going to invest for the storage material. That is going to be happen. So always there is a counterpart for that solar. Anyways, wind, when we are going to talk about a wind energy, then wind is totally going to depend upon the location. In the south side, you are going to see so many windmills over there, right? Again, there must be a plain area, very high height over there, maintenance is very high. So that is going a lot of factor going to be added over there. Although we are going to produce around 1 lakh megawatt of this wind energy from there, right? We are going to utilize that. And then again the geothermal energy, again location specific, right? So in hill area, sometimes we get in a lake, we do have a geothermal location over there, so where ONGC is working right now. And there are some other locations in Himachal, let us say in Mandi, there is one place, Manikan, so a lot of heat is going to be, hot water you can see over there. But it depends upon then how we are going to utilize this. Or for example, ocean is there, so we are going to use the OTEC, right? Ocean thermal energy, we are going to use that. So here what we are going to do is, in our water, we are going to use a delta T on a surface, and below that surface, 1000 meter we are going to below, and the delta T we are going to find out, and we are going to utilize that, right? Or ocean waves, that waves are going to be generated. What we are going to do is, the wave, as the wave is very high, we are going to open the barricades, it goes from one side, we are going to close that barricade, and then we are going to use the turbines over there, and we are going to throw that water on the turbines, and we are going to generate electricity. There are a lot of ways to generate electricity. The thing is that whatever be the technology you are going to use for the generation of that energy, how you are going to utilize and when you are going to utilize. When is very important. It is not about that, okay, in a daytime you are going to utilize all the energies. Although you can have a different application for that. For example, you are going to say about the irrigation. That's the main topic. Okay, you run your pump with the solar energy, right? And you can use it. Fine, but this, at this moment, the government is fully focusing on the topic, or the major of the researchers are focusing on that, they are shifting their focus, that how to store this energy. That is going to be a major important factor. Fine? Right. Okay, this slide is very common slide. You have already seen, maybe this one has shared it to you. I was looking on their slide. So this is going to show you that how the water stress is going to be in a worldwide, right? There are many countries like if you see the Arab countries, right, Qatar, Oman or UAE, right, your Israel, Palestine, or they are going to be under very high stress level of the water. They need to have that, right? So, but there are few countries like India is also included in that, and Australia or some other parts of the countries are there. They are going to feel around 80% of the water scarcity. that is going to be there in coming future, and it is going to be by 2050 or 40 they have predicted that this is going to be happen in reality, right? And we are seeing it. Fine. So reason for now, what is the thing is that we cannot depend upon the conventional source of the water, but we were seeing over there that okay, we have a well over there, rivers are there, mountains are. Last time you have seen the same this thing in the Kashmir as well, how the temperature has been varied, right? It's a drastically variation of the temperature, which we were not seeing over there because their accommodation and all those things are as per the winters, or that at the most of the 30-degree temperature or 32. But it has gone to a near around 40, 37, 38, 39. So it is going to be, I mean, the conditions are going to be changed, right? Okay, fine. Now, so what is the method we can talk about that we want to generate the water from the atmospheric air? That is the thing is there. Now we do have a 3 to 4 methods I have given over there, 4 methods. One is by using the water generation from atmospheric air. So if you are using a vapor compression refrigeration system, you know it, I hope so, because the air conditioner we do have, or your refrigerator, we are going to call it as a vapor compression. It is working on the vapor compression refrigeration system. So we do have some refrigerant over there. It is going to float on all those 4 components over there, right? And we are going to compress that in condenser. We are going to exchange that heat in we are going to compress in the compressor. Then condenser is there. It is going to exchange the heat in your condenser part, and then we are going to have an expander over there. It is going to have a low pressure over there, and then we are going to throw it to the your evaporator part. So evaporator is your ice cube box in your refrigerator, or if you say this room, so this is your evaporator where your air conditioner is going to throw the heat over there, or it is going to extract the heat. That is the main thing over there. So how we are going to do is, we are going to take a coil, evaporator coil, and we are going to throw that air on that coil, and it is going to get condensed. And we have already seen this phenomena very commonly when it is very humid climate condition, right? So in northern we see it is a very common way to produce the water. But although we are going to use an electricity over there, and it is going to be a costly method to generate the water, right? Okay. So next method is we are going to use radiative cooling. That is what we are going to do is in radiative cooling. What is the same thing is over there, that we do have a simple cool surface over there. We are going to throw that humid air, or that is the condensation is going to be take place now on your roof of this building is going on. That is a kind of dew point collection you can do. But water is coming as soon as it is going to be condensed on that cool surface, right? The next is we do have water produced by convection induced or controlled in a structure. So what we are going to do, we do have a column of the structure, and we are going to make it on a very high, thousands or hundreds of thousands of meters to the atmospheric air, right? And what is going to happen? There is a pressure difference over there. Because of that pressure difference, what will happen? The condensation will start to take place, and on the bottom of that, if we attach some container over there, we can collect that water. That is another method, right? And then the last one we do have is that water generation from atmospheric air using desiccant materials. Now desiccant materials, you know it that desiccant material has a property that it absorbs moisture from the atmospheric air, and that is due to the pressure difference. Okay, you understand it in another way that we do have a very common naturally available desiccant materials. For example, jaggery. Jaggery is there. So what you do is you expose that to the humid environment. It absorbs the moisture and it starts to melt. That's the one way. Or another very common material, if you see in the nature, is your multani mitti, which apply on the face. That is also used for the absorption of the moisture, right? But another way is a chemical method, that how we are going to utilize all those chemicals. Although this desiccant material was used by the Navy peoples when they moved in the ships and they carry their food products over there. So in order to preserve it for a longer duration, they keep all those products with this desiccant material, right? And they can use it. They were able to keep their food safe for a longer duration. But now what they were doing is they were just most commonly desiccant material silica gel, they were using it and they were throwing it when they were coming to the base and they were throwing it. So now what is the proposed utilization is that what we are going to do is we are going to this regenerate that desiccant material through the sun, and then we are going to utilize and then that regenerated is moisture is we are going to collect that moisture and going to produce some quantity of the water, right? So now there are three steps what has been followed for this water process. One is your absorption of the water. Now I'm not using the word absorption, I'm using the word adsorption, right? So it is a solid surface on which some moisture is going to be condensed and there are isotherms over there. Nowadays there are a lot of work is going on to modify the isotherms, right? So where the water is going to be gets stored over there, right? So we have a different shape, S type isotherm is there, Z type isotherm is there. So different kind of shapes we can modify as per our requirement, fine. And when this material is exposed to the atmospheric air, so moisture is going to be get condensed over there, then we are going to regenerate that temperature. Now whatever be the thing I'm going to discuss over there, it's the medium temperature application. Medium temperature application up to the 50 degree or 60 degree, right? So then we do have a condensation along the glass. So what we are going to do is in a daytime we are going to expose that material to the atmospheric air. It is going to be get condensed on some particular surface, right? Okay. Now we do have an experimental setup. This kind of very easy setup. I mean, this is one of basic setup we have used over there for adsorption, for regenerating the desiccant material. And these are the different desiccant materials which have been used. One is your silica gel, which is in a blue color. So we have a color indicated kind of desiccant materials we use. If it is in a dry condition, it is going to be blue. If it is in a wet condition, in a below, you can see the pink color. So if pink color is there, it means it has absorbed the moisture from the air. Now the next term is activated carbon is there. So or activating, in case of activated carbon, what we are going to do, it is the same thing is going to be absorption of the moisture, but the quantity of absorbed moisture is very less. And another thing is your activated alumina. It is again modified desiccant material. But the thing is, and we do have another thing is zeolites. Now except this silica gel, if you are going to use the activated carbon or activated alumina, all these kind of materials, they are required high regeneration temperature, right? Let us say we want to produce the water in the Rajasthan climatic conditions. There it will absorb the moisture from the air, but if I want to regenerate, it is a very good in that climatic condition, because there you will find a good intensity over there and it will get regenerate. So it requires around 150 degrees C, right? Whereas silica gel is going to regenerate within 50 to 60 degrees C. That is very easy one, right? Okay. Now this is the experimental setup which is used over there. Three different kinds of setups have been used over there, and in order to absorb this moisture, what we were doing is we were keeping this side windows open, and we were keeping this for a full night open, right? And then the moisture was coming over there, it was getting absorbed by this one, and the same thing was getting. So we have kept the three setup intentionally. Now once it is in dry condition, it is going to be the blue color, right? Okay. So this is the setup design, how it is going to the blue color, but it releases the moisture, and we are going to take that condensate in the bottle, right? It seems to be a basic design, but after going through a lot of calculations and experimental verifications, we have gone through we have arrived to this conditions over there. Now how we are going to see the adsorption over there, mass flow rate and this moisture. Now when we have gone for the simulation results and we want to verify some of its results with experimental results, so we have gone for the variation of we have taken the three setup over there, and we have taken the three heights to that mesh tray. Now desiccant bed, if I say 0.16 meter, 0.22 meter, and these heights have been kept, and we have exposed these three materials. The same process happened. 10 meter, and box 3 is going to be there, 0.22 meter. Although it was on the bottom one layer over there, and absorption was very less, whereas the material which is at the blue color, that is the 10 meter, right? It was going to absorb the very high, because obviously the tray was in the middle of this window, and it is going to be absorbed by on the both sides. So it was the complete absorption was over there, right? And but when we went for the this regeneration of this desiccated material, in that case we have seen the box 3, 0.22 meter was going to be generate the more water as compared to the rest of this heights, right? So what we have done is, okay, let us say that what we have done is, okay, because my ultimate aim was to generate the water, right? So I have kept this parameter as a fix over there, right? For the next parameter, what we have done is that we have now ultimately we have to see that what should be the perfect angle in the climate as per the climatic condition. What should be, I mean, as per the location, what should be the perfect angle for my experimental setup. So we have gone for the 3 variations of angle, and this is what is happening over there is we are using this is as a weighing machine at the bottom, right? The experimental setup is there, so we were keeping this 20 degree, 10 degree and the 30 degree angle over there, and we have seen the water produced by this angle. The 30 degree angle was going to the perfect water. Now again, if you see that all these experiments have been performed in the NIT Kurukshetra. So there we have seen that my altitude, latitude angle, it is approximate 30 to 32 degree, right? So it is going to be there that if my setup is going to be in a perpendicular condition over there as per my latitude angle, so it is going to give me a perfect conditions. And obviously, when we are going to talk about, if you have seen about the evacuated tubes, which we generally use over there, this kind of tubes, black color tubes, if you have seen for heating of the water on the roof, you have seen over there. 2 types. One is your flat plate collector, another one is your evacuated tube collector. In a flat plate, problem is that when your sun is going to rise and it is going to be get down over there, you are not going to get the much intensity for the heating purpose. But when you are going to talk about the tube over there, all the time from the morning time to the evening time, you are going to have this heating from all the sides. That is going to be happening, and there is some nickel, chromium nickel coating is done inside that black color coating, and we are going to, and that is going to absorb the heat, right? That is going to be happen. So if you see, if you have an experiment or if you have gone through that tube, so if you measure the rise in temperature, it has within half an hour you're going to see around 150 degrees C temperature over there. That is the kind of rise. So in that evacuated tubes, we do have a 2 concentric tubes which is fused together like this one at one end, and a vacuum is maintained inside that, right? So why do we maintain the vacuum? In order to avoid the transmission losses, right? Okay, perfect vacuum is there. It is going to strike. It is going to heat that particular black metal over black surface over there, and black surface is going to give the heat to that tube over there. Fine. So, anyways, so we have just generally went for the fixing of these 2 angles over there, and then was the thickness. Now, thickness is again important parameter. So I hope you have you know about the Fourier law. So there, but we have used that Fourier law, and accordingly we have verified that, okay, I'm going to use a more thicker glass tube over there, is it is going to be provided more hindrance to the radiations over there, right? So the 3 mm results were found to be better with the angle 30 degree and my depth of my bed as a 0.22 meter, right? And then these are the glazings. Now glazing is an important parameter. So because I got this idea when we were talking about the desalination system or the distillation system. Now in distillation or desalination system, the basic idea is that you need to have a water over there. Whether it is a brackish water or the clear water, but you have to have a water over there, right? And there what was happening over there, because water is there, so automatically some surface was getting cool over there from one side, and it was very easy to go for the condensation. That was happening over there. And although what we were thinking is, if we are going to have this kind of glazing over there, different glazings over there, we are going to provide a channel over there so that the air could flow and you could have a low temperature. I mean, you could have a delta T over there in order to have an condensation. That was what idea was there. But that idea couldn't work over there. Only the single glazing was a perfect one, because rest of the glazings were adding as an my same glass thickness. It is going to add as a glass thickness only. So single glazing was going to be having a perfect results. That we do have a maximum generation of the water by having the single glazings only. Now, what we have done is, now we have a different desiccant materials we have used it. That is silica gel with all those conditions, 0.22 meters at depth of my desiccant bed, 30-degree angle as per the latitude angle of the location, and thickness as a 3 mm of the glass, and we have used another thing is your single glazing. That was what we were going to use it. So different 3 materials have been used over there, and in adsorption rate we have gone again for that. What is happening over there is, it was high for the silica gel only, and the water generation by the silica gel was the high as compared to the another desiccant material, and this issue have been seen over there. It was not going to produce because it is a high temperature regeneration materials are there, right? And we cannot use it for the in normal low temperature climatic conditions. It is not going to release the water. Then what we have done is that year-round performance have been checked for the generation of the water. All these materials have been kept, and this silica gel have been kept over there along with some other materials, and we checked it that how much water we can produce in throughout the year, right? So we have got that in the month of the March we were getting, when we have a solar intensity as a 706, right, watt per meter square. It was total yield was going to be 260 ml per kg per day. Now the results have been for given over there is for kg, 1 kg of the material. Now you assume that if you want to have a high amount of quantity of the water, then what you need to scale up it accordingly. For example, let us say if you want to have a water for in a school, you can use the roof of that school, and you can use these kind of trays over there. You give a latitude angle as per the location, and accordingly you can have the water from there. So you can utilize it as per the requirement, right? Okay. So now this was the condition over there. Minimum temperature was at 12 degree and maximum was going to be the 24 degree on that particular month we have seen over there, right? Variation. Now again the analysis was done for whatever the water we have got from there, that is it, can we use it for the drinking purpose? That was the main motive over there. Can we tackle that problem? Yes. The pH value was coming out 7.2. So if we have a water which is having a pH value 6.5 to 7.5, we call it as a fresh water, right? But its value was coming out as a 7, so it is coming in a neutral range, right? And we can use it. Fine. Okay. So another parameter was nothing going to be there. It was within acceptable limit. Total hardness was 230, right? And potassium. All these parameters are going to be very, very less, which is acceptable for the drinking purpose. Now, the next purpose was, which is from the agricultural point of view, is that what we have done is we have used a vermiculite. Now, initially I was working with this solid desiccant materials over there, silica gel and all those materials. But when I was going through the literature, then I have seen that calcium chloride was the most prominent salt which we were using there. But the issue was with this material was its corrosive nature is there, and it is getting in a liquid form, so it was difficult to contain that particular this salt over there. So what we have done is we have tried to use the vermiculite or the sawwood floral form or jute or the burnt clay, and we used all this material with the calcium chloride. Now what we were doing is we have done is the different sample have been prepared of this composite desiccant material. So for that, what we have done is host matrix. So host matrix is your vermiculite. Let us say I have taken it vermiculite, I have kept it for 80 degree and I dried it, right? I dehumidified it. Okay. And then what we have done is the calcium chloride aqueous solution have been formed for the different concentration, and we have just clubbed these two, and we have heated it up to the 100 degree in order to remove the water. Now it was a perfect combination for the adsorption, right? If my calcium chloride is going to adsorb any moisture over there, immediately when it is that moisture is going to be disseminated into the host matrix. That was going to be happen over there. So what we have done is, now we have gone for the SAM analysis over there. So you see we do have a different pores over there, right? And when we have used this calcium chloride, we have seen this kind of structure over there. So it was completely filled over there, no pore was there. Or if there is any pore, it was very, very less over there, right? So we have used the same, now this is the concentration, different concentration have been used for the calcium chloride, 9, 16, 23, 28, 33 and 37%. Beyond this we cannot go because the residue was going to be very, very high as we were moving beyond this concentration, right? So we kept this maximum concentration as a 37%. And these again, these samples, prepared samples have been tested in these conditions over there. And we have seen, this is for concentration formula, empirical relations have been used, basic formula, and this is for the efficiency. The main thing was the adsorption rate. We were trying to analyze it, how the adsorption is going to be very high over there. So this is for just 6 samples have been basically prepared, 9, 16 and one more concentration is there. But we have seen that 37% sample was having a good adsorption. That's the sample number 6. It is going to be having very high adsorption rate as compared to the another 6 samples. So other 5 samples. Now when we have used these samples for the generation of the water, that how it is going to be. So sample 3 is going to be generate because it is having first 3 samples having a high concentration of the calcium chloride, and another 6 sample, the last 6 sample was going to generate the more water as compared to the other 5 samples. The thing is that more calcium chloride was there, it is going to absorb the more moisture from the air, and it is going to, when we were heating it, so medium temperature application we are giving it, and it was going to release the more moisture from that, and we are condensing this unit. So this is the calcium chloride concentration 33%, overall efficiency we were judging it, right? Now, so now again what is done over there is that it has been checked for the water generated, produced by all these odd combinations. So we have seen that some of the water is there, like fluoroform is used over there. So you know it because when we go for the decoration, we use a fluoroform. We dip that inside the water, and if I am going to put a flower or like something else, it will be in a water inside that. So it will keep the that plant will keep on taking the water from that foam over there, which is not a fluoroform, right? But it was when we use that fluoroform over there, it was going to be produce the water, but that was coming in the acidic range over there, 5.4 for pH value. Whereas the rest of the material was acceptable for the fresh water range. That was going to be happen over there. Now, so again we have used different materials over there, jute, vermiculite, or the burnt clay is used over there, and their analysis have been done for the adsorption and adsorption rate with the humidity, right? And it has seen that okay, this is the maximum water is produced by the vermiculite and sawwood. So 2 combination we have used. The main idea is that when we have a vermiculite, all the jute is over there, the vermiculite and the sawwood is there, so more pores were coming into picture over there, and it was going to absorb a good amount of calcium chloride. That was the main thing over there, right? And its regeneration is very easy because we are going to use a wood over there, so it will not take much time to provide a heat to it, and it will absorb that heat and it will release the moisture, right? As compared to the other materials over there. Now the thing is that when we have gone for the water produced over there, that how much it will be cost effective. That was the thing over there, we were checking it. So what we have done is we have used the annual salvage value, shape linking factor, and annual cost over there, how we are going to get it. And different, like my structure was over there, I have given the different amount over there, and after selling it, I was just getting a 250 rupees. That was what my experimental cost was there. So finally, what we have done is different parameters have been analyzed, right? So these are the annual, and we have gone for the annual yield for the silica gel water. Let us say how much water have been produced over there. 94.9 liter kg per year of the water has been produced by using the single 1 kg of the material by the silica gel and activated alumina and the molecular sieve. Molecular sieve zeolites, which was not that much of effective over there. And but the cost was coming over 5.14 per liter. It was coming out over there. And the material which is used for the composite desiccant material, we have seen the different desiccant materials, and in that case, this was the different quantity of the water which has been generated annually yield we have calculated for that, and it has been found that okay, overall we are going to have this quantity of the water generated for that. So ultimately, this the material which I was telling about, that this is going to be the best material for the generation composite desiccant material. It is going to generate the water 477.56 liter annually. It has generated the water, and we have got its cost at a 6.71 per liter. Fine. So a few references have been used over there. Although this is a very basic technology we have used over there. But now what we have done is one more project is I'm working on that, and it is an almost going to be start within a very few years. So within a few months it is going to be start. So what we have done is we are going to use a both side open evacuated tubes over there, which I was discussing over there, and I'm going to utilize the humidity over there with the help of the desiccant wheel. One wheel is desiccant wheel we are going to utilize for generation of the water. It is expected that within 3 to 4 hours it is going to produce around 9 to 10 liter of the water. So you can utilize that water, let us say it depends upon where you want to apply. If you want to use for the drip irrigation system, you go for that. If you want to utilize for the drinking purpose, you go for that, right? It depends upon where you want to utilize. But rather than depending upon the conventional method, the desalination distillation, which is in more prevalent in the southern part of the country, but in northern we need to have this kind of technology, which is based upon the atmospheric air, right? So that we could generate the water from there. This is the more thing over there, and these are the few references I have used for doing my work over there. Okay, fine. So, any questions if you have, please.
I have one question.
Yeah.
About your research. The quality of water that you showed, that you have analyzed, does it change from different places? Will it change from different cities?
I have done this experiment at one place. Let us say if you are using now if you are going to use the atmospheric air of Delhi,
Yes,
it is going to be a very, it is a very bad condition, right? So I have not checked that condition, but yes, it will affect. It will affect of that
because there's a
location.
lot of other
Other particles are there. So, but the solution for that is we can use the filter. If you have a good quantity of water produced over there, you add a simple filter bed over there, and you pass it through it. This is the same thing what we are doing with the final year project I have gone through. So we are going to utilize the Peltier effect over there, Peltier principle over there, and what we are going to do is we are going to utilize that heat, this delta T we are going to utilize over there, and with the help of that delta T, what we are going to do is we are going to cool one side of my setup over there, and the condensation will be over there. So now the thing is, the problem which you were telling is, what we have done is that this is the kind of, let us say this is Peltier 4 modules we are going to use over there, 4 different modules, and the one side is going to be getting cool, and below that we have attached that carbon bed over there, so that the moisture is getting condensed over there, it is going to pass through that bed, and we are going to get the filtered water over there. So this can be the alternate for that. This is a very basic research we have done over there. This is just to start the concept over there, that how we are going to move, how we are going to tackle this kind of problem. This is way back 2012 we were going to start, where the India was not thinking about that this can be an alternate for producing the water. But nowadays, slowly we are moving to the more technical things over there, that how we can incorporate, like Peltier effect we can use. We are going to use the both open-ended tube. In India, we are not going to get there is no industry for that we are going to get the evacuated tubes over there. If it is available over there, that is made of China, and it is coming over there, it is a fused one side open tube only. But the both end open tube, just one work we were doing over there is with the NICE, the National Institute of Solar Energy, Gurgaon. So we are doing over there. So we have ordered those tubes from the China, from both ended open tubes. So it is we don't have any industry over there. This is again a new prospect for anyone who want to start a business, or but again the cost factor is coming into picture. So a lot of things are there. Fine. Okay. So any
One
yeah.
more question, sir. About the capacity of water that you are getting, have in your this experience of research, have you checked the capacity of water that you are getting in the daytime or night? What is the best time?
Yeah, the thing is that in a daytime only we were having in a solar intensity. That was the thing over there. So, but in the night time, what we have done is, this I have not shown over there is, we were using the phase change material. Yes, we have used the phase change material, and that was going to be in a daytime. We have used a concentrator over there, so that those concentrators were melting down. Let us say wax is there. So wax is melted in a daytime. In a evening time, as intensity went down, so I utilized that wax to provide the heat. Now the same thing is, I was the same concept have been used in a lathe to heat the room, and they were using that same concept for the drying purpose. Fine. Yeah.